Good morning. Welcome, and thank you for getting up at or before 8:30 on the last day of PDC to come to our security symposium. I'm Steve Lipner, Director of Security Engineering Strategy at Microsoft, and I'll be introducing the morning and kicking off with a brief overview of the security development lifecycle, which is the subject of our presentation today. I'll be followed by several other Microsoft people. Michael Howard from our team, who is the co-author of the book that I believe you're being given, and then Adam Barker, Graham Elliott, and David Palmer from Westpac Bank, all in Australia. This is South Pacific morning. Michael's a New Zealander, and our other speakers are from Australia. So I feel a little out of place, although again I'm from Texas, and I guess that's at least south, if not South Pacific. Let me just give you a brief overview of the day's proceedings. Whoop. Whoa. Well, that's a good start. Okay. So Michael is going to kick off with an introduction to threat modeling, and then we're going to have a brief break. Following that, Graham will talk about secure coding practices. David will give us a brief summary of some of the activities that Westpac has gone forward with to implement the SDL in their environment, and then Adam will finish up with a discussion of testing, final security reviews, and response planning. So with that, let's get started. I want to just start out by giving you a little history. This is some stuff that many of you probably already know, but maybe a few new things as well. Microsoft actually didn't just come to security over the last few years. As early as the 1990s, the team that built Windows NT had previously worked on an operating system project at Digital Equipment, and that project actually had a target of achieving what was then called a B2 system, an evaluated system under the then United States security evaluation regime. That sort of system requires a high degree of design rigor, high degree of structuring, a high degree of care in countering threats in the process of designing and building the system. And those principles and much of the design ideas carried forward to NT. And in fact, I have correspondence in my office from the NT security program manager proposing a B2 evaluation to the National Security Agency back in 1991 or 92. Of course, the Orange Book pretty much went away, higher level evaluations went away, and so the evaluation was never carried forward. We've gone for other evaluations with Windows over the years. But the design principles, the design structure of NT, which of course became the subsequent Windows releases, really remained intact through that time. Despite that, as we added networking, as we added web browsing, as we added some other features to Windows, into the late 90s, we started to see this, what I call the economy of vulnerability finders. The folks who would take an application or operating system and basically bang away at it until they could find a hole, find a vulnerability, find an exploitable flaw, and then either post that directly to the web, post it to a mailing list, or send it into Microsoft and ask Microsoft to fix it and tell them how and give them credit for doing so. The vulnerability finder phenomenon led Microsoft to form the Security Response Team, which is the predecessor of today's Microsoft Security Response Center. And that organization was formed both to drive the technical activities, fixing the vulnerabilities, and the community activities, letting people know that the fixes were available, cooperating with the vulnerability finders so that they wouldn't, would basically understand the importance of reporting responsibly and not making vulnerabilities public until Microsoft had a fix. Internal to Microsoft, about that same period, we formed what was called the Security Task Force, which was a cross-organizational group designed to look at the way we built software and see what we needed to do to build more secure software. Michael was actually a part of that, as were a number of other people who were still involved with security at Microsoft. And basically, the findings of the task force, I was looking at them in preparation for this symposium, pretty well stand up today. The rudiments of threat modeling, the rudiments of a focus on code review, the rudiments of a focus on security testing, the rudiments of a lot of focus on tools and buffer overruns. And out of the task force recommendations came what was called the Secure Windows Initiative. That was a team that was formed to do design reviews and to some extent code reviews of Windows components and identify vulnerabilities, identify potential flaws, and file the bugs to get teams to fix them. Well, the Secure Windows Initiative team was small. The code base was big. And so we pretty quickly determined that that wasn't the right solution, that wasn't the scalable solution. During the XP era, the XP development era, we moved to a model where the Secure Windows Initiative team would focus on training, on tool requirements and tools, and on working with teams what we called security days to help them do their own reviews, to help them find and fix their own security bugs, and started to scale things out. And that was the situation in late 2001. And I want to just give you a video that sort of gives you a context of the phenomena we were seeing and how we moved to the next level with security development practices. And to do that, I have to find the other screen and hit play.
My story about Slammer is a little bit unique. I was actually having a car stereo put in my Jeep.
I was lying in bed early one Saturday morning and heard it on the radio.
The internet today was taken out by a worm in Microsoft SQL Server software.
First time I heard it, I actually didn't believe it, so I went back to sleep.
And so I was telling them, put the car back together, I've got to go.
The second time I heard it that I believed it, jumped out of bed and came into Microsoft and worked with the team to help deal with the customer issues that were happening very much in real time. The big issue that we heard from customers was really understanding what they need to do to stop Slammer.
They looked to Microsoft to be the authoritative source of guidance about the incident.
The fact that Microsoft, unfortunately, was facing Slammer in our internal operations was a great opportunity for us to learn a lot about what customers were facing, because we were very much facing it right here on the Microsoft campus.
We've actually taken a step back from the development of software and implemented something known as the Security Development Lifecycle. And what the Security Development Lifecycle actually does for the company and for our developers is it really starts the security process from the beginning.
Security doesn't have the same level of pizzazz that other kinds of innovations might have in terms of our culture here at Microsoft. It's been probably the hardest thing to develop and the hardest thing to change.
When a developer is thinking about a new feature that they want to put into our products, they start to think first, how could this feature be misused?
One of the things that we found to be very effective is to spend a lot of time talking about it, to make sure that people understand really the customer issue behind security and realizing the importance of this in a way that becomes very tangible for everyone involved in the development lifecycle.
And once you've enumerated maybe the ways it can be misused, you can then work to implement that feature in a more secure way.
In Windows Vista, one of the things we're really focused on is making sure that we can reduce the number of cases where a user or a system service has to run with the admin privilege turned on. With the admin privilege turned on, the risk of vulnerability causing large impact is obviously much greater. I think having a cool feature has always been important. Shipping on time has always been important. But security has now got a place in that prioritization is very, very high. If there were three things that every developer should think about as they're writing more secure code, the most important thing that I would look at is making sure that they understand the different ways that a bad person might try to attack their software. Job number two, I think, is to make sure that you understand some of the key approaches that have been developed in the industry, some by Microsoft, around how to write more secure products. And in particular, this notion of something called threat modeling. Microsoft's done a lot of work to make sure that our best practices are available in a way that's repeatable. The last area that I think is important is to make sure that you're compatible with key approaches to providing protection, whether it's having firewalls turned on, compatible with antivirus software. I'm really looking through to make sure that the use of your software doesn't limit the functionality or the ability of software that's there to protect you. At the end of the day, what I've observed is that the culture has changed when decisions are made differently than they would have been in the past, because security becomes a very important dimension upon which those decisions are made. In the short term, the investment in security may feel very painful. In the long term, it always pays off.
So that's an introduction to the SDL and an introduction to how we got here. 2001, of course, Slammer was a little later, of course. 2001 was the year of Code Red and NIMDA, and that was really a wake-up call for Microsoft. And in the aftermath of Code Red, of NIMDA, of the launch of Windows XP, we committed as a company, beginning with a company-wide email from Bill Gates, to the notion of trustworthy computing. The principles are shown on the slide here: security, privacy, reliability, business practices, business integrity. That commitment was announced as something that we weren't going to solve overnight. We're not going to say, well, we're going to commit to security in 6 months, it'll be done. The email actually said it was a 10-year commitment. Security is a problem that's probably never solved as such. You constantly have to work on it. But the commitment is there, and one of the things that Michael and I will tell you from driving the process internally is that the executive commitment, the executive force behind doing the SDL, behind doing secure software, has been a huge help to us in actually getting these changes made. And what are the changes around security? This is a one-slide produced by marketing graphic of the security development life cycle. We view the way we build software today as really a circle. On the outside, you have the development process, standard development process, beginning with product development around through internal testing, beta testing, and deployment and deployment. And then inside of that, in orange, you have the components of the security development lifecycle that are overlaid on the development process at the design, coding, testing, and final release stages. And we'll talk about each of those in the subsequent presentations. One of the things I just do want to point out here, we show it as a circle. At the deployment end, we have incident response, which is what we do to respond to things like Slammer or the more recent Zotab worm. And we have the Security Response Center. Security Response Center is really a key component of our overall security lifecycle process. Why? Because vulnerabilities will be found. You can't build perfect software. People keep inventing new attacks. And as a result of that, it's important for us both to respond to those and respond effectively and completely, and also to use them as learning, so that the next time around through the cycle, what we learn in the response center gets reflected back in how we build the new generations of software. And that's proven very effective to us, not only in responding to vulnerabilities, but extending them, inventing new kinds of attacks, and then eliminating those new kinds of attacks before product shipped. So what's the security development cycle, life cycle, shown on the slide here? It's mandatory Microsoft software that touches the internet, that is used in an enterprise or organization, or is used to handle personal or sensitive private information, is mandated to complete the security development life cycle before release. It's an evolving process. I showed you that, the cycle from new discovery of threats, new technology, around to new variations of the process. It's compatible with real-world development. I've been involved a lot over the years with some of the theoretical and government-sponsored security initiatives. We've learned a lot from them, but the SDL is our cut at a process that can actually be applied to build software that will be shipped in a reasonable time and that customers will want to buy. And that's a significant payoff for us. And finally, it works. I'm going to talk in a second about the way it works. SDL, we believe, puts us on a path toward shipping customers more secure software. This is the detailed breakout slide of SDL, the Microsoft development cycle shown as a waterfall, which it's really not, it's really a spiral, but it's shown at the bottom. And then the steps of the SDL: security training, threat modeling, development, testing, final security review, servicing and response at the top. As we go through the day's sessions, we'll highlight those top blue boxes with sort of a "you are here," so you'll understand where in the process the content that you're hearing fits. Let me just talk about how we're doing. A few months ago, one of the chief security officers of a big customer talking to my boss, Mike Nash, the fellow with the short haircut, not with no haircut in the video, and telling him, hey, you know, TWC isn't working, the SDL's failed. I've looked at your situation. You've released 23 security bulletins in the first 4 months of 2005. It's a third of the way. You're going to do 69 through the entire year. You did 45 in last year. TWC must be failing. But the reality, we cut this now at fiscal years because we want to make the point about a particular product family. So we cut it fiscal years, July 2003 to June 2004, and then July 2004 to June 2005 is fiscal 05. And we say, yes, indeed, the bulletins increased fiscal 4 to fiscal 5. But if you look at the details, what you find is that in the Windows client component, the number actually went from 35 for the down level versions, Windows 2000 Pro and XP Service Pack 1, down to 18 with Windows XP Service Pack 2. So we apply the SDL processes, we get about a factor of 2 improvement. Other products, the top chart drills in on the browser, on IE. IE6 SP1, 64 bulletins. IE6 SP, I think that's vulnerabilities rather than bulletins. 64 vulnerabilities versus IE6 SP2, 27. Exchange 2000 versus Exchange Server 2003, 8-5. Office, SQL Server. SQL Server 2000 is kind of a neat story. The same week as the slammer worm hit, we released SQL Server 2000 Service Pack 3. And Service Pack 3 had gone through what we then called a security push. Some of the elements of the SDL in a pretty early form. And they released it on Monday, and then the slammer worm was released on Friday. What's happened since that January 2003 release of Service Pack 3 is that we've issued 3 security bulletins against SQL Server 2000 Service Pack 3. None of them critical compared to the bulletin count in the prior year. And that's been a huge payoff for us and for our customers who are using SQL Server, and really a great demonstration of the effectiveness of the process. Just some industry comparisons. Windows Server 2003, really the first product to go through all the key elements of the process, including final security review, comparing Windows Server 2003 versus Red Hat Linux, operating system to operating system, in-box components, blue Microsoft, red Hat. And another cut, which I think is even more interesting, the scenario-based view, web server role and database role. The database is scenario is paying off from the effectiveness of SQL Server 2000 Service Pack 3, as well as Windows Server 2003. In the web server role, I don't have a slide on it because it's just a point. In the web server role, IIS-6, the web server component of Windows Server 2003, has had one security vulnerability since the release of Windows Server in April of 2003. Huge change from IIS 4 and 5, a huge payoff for the threat modeling and new design techniques that we applied. So what does all this mean for you? Well, the security development lifecycle is a key part of our development process at this point, and so that helps us to improve the security of the software that we ship to you. But it also is a process that we think is really applicable to customer and ISV development activities. The reason we say that is that as we make progress with the SDL, as it evolves, as we continue to improve our processes and chase the vulnerabilities out of software with each new release, we think we're going to make it harder and harder for the people who find vulnerabilities and write attacks. And there are two possibilities. One of them is that they're going to give up and go to flipping burgers. The other is they're going to find some other software to attack. And we don't want them to attack our customers' software either. So we're trying to communicate the steps of the SDL, the way we do it, the effectiveness of the process to customers and ISVs in the hopes that they'll apply these lessons and be able to build more secure software, make the internet a safer place, make their own businesses safer and more secure. So with that, I would like to turn the stage over to Michael Howard, Senior Program Manager in the Secure Windows Initiative team, and he's going to walk you through threat modeling. Michael.
Thank you very much, Steve. Again, I'd like to thank everyone for attending. I don't know about you, I'm not a morning person at all, and I got absolutely no sleep last night, so I'm kind of grumpy this morning. Anyway, so I want to talk about a subject that's near and dear to my heart, which is threat modeling. If I had my hands tied behind my back and I could only do one thing at Microsoft, and I don't, but if I could only do one thing, and it was threat modeling, better security code reviews, or penetration testing, I'll do threat modeling every day of the week. Absolutely. It helps you find issues before you've written a lick of code, before you've committed anything to disk. It really helps you just understand whether the design is actually a good design or not from a security perspective. And we've learned a lot about the threat modeling process over the last couple of years. Even over literally over the last 9 months, we've learned a lot about threat modeling and got a lot of feedback on the threat modeling process and substantially improved it to make it a much more digestible process. So a quick overview of threat modeling and why it's important. Why even bother doing it? I've sort of already alluded to that. But the really important point is people need to understand that when they're building software, your software will be attacked. I mean, the very fact that you are deploying something that's internet connected, listening on a port, means that people will start sniffing around that thing and find out ways they can potentially compromise the system. So it's really important to understand, how can this thing be compromised? Do I have appropriate defenses in place? It also helps you work on defining some of the other security-related activities, such as penetration testing, such as how to review the code, which code needs to be reviewed the most, how do I reduce the attack surface. A lot of these things actually feed off of the threat modeling process. And as Steve sort of alluded to before, We'll touch on different parts of the SDL process, and we'll show you where different events in SDL occur. So threat modeling is relatively early on in the process. You can do threat modeling later in the process, but it becomes part of a bug hunting exercise at that point. And frankly, that's not the best use of your time. You've already built stuff, you've already committed bits to disk, you've already got the design basically done, and then you go and find some bugs. Unfortunately, we know that that's just not a scalable process. You know, write stuff, find bugs. That's just not a scalable process. The whole point of the threat modeling exercise is to get the design more secure before you start building it. And so it's much better to do the threat modeling exercise as early as possible in the process rather than later. I want to explain some really important definitions, and the reason why I'm adding these definitions is because of sheer pain I've experienced in the past. I remember presenting to some professors about threat modeling for the very first time, and we got into an argument for 30 minutes about the definition of the word threat, as you can only do with professors. And so we decided that what we would do is from that point onwards, we would put the definitions that we were using in any material that we use, so that way there will be no confusion. So first of all, there's a threat agent. It's a bad guy, someone who can do bad things to you. A threat is the bad guy's goal, what they want to achieve. The vulnerability is just a flaw in the system. From a threat modeling perspective, it's an unmitigated threat. It's something that you haven't protected against. An asset is something that you care about. It's something of value to you and of value to the attacker. And finally, an attack is when, and there's some very important words in here, when a sufficiently motivated and sufficiently skilled threat agent takes advantage of a vulnerability. So these are the definitions that I will use throughout the rest of this presentation. Now, the process that we have had in place prior to this came under quite a bit of criticism, and quite rightly so. And the ones I really want to point out are the first two bullets. The first one is requiring too much security expertise. We absolutely recognize that. There was a lot of security expertise required. And in fact, when we drilled down and we asked people, what do you mean it requires too much security expertise? Which parts of the process requires the expertise? And it turned out the expertise was actually in building the threat trees. So we've done away with the threat trees. Actually, we haven't really done away with the threat trees. What we've done is we've found that there are threat tree patterns. There are patterns of conditions that can lead to threats. And so what we've done is built about a dozen threat trees that are sort of the canonical threat trees and the list of conditions that can exist. Think about it, right? So you tell someone who knows nothing about security whatsoever to go and come up with a list of all the possible conditions that could exist that lead to a vulnerability being real or a threat being real. Unless they're a security expert, they've got no idea. No idea whatsoever. And they spend like the next 6 hours floundering, building threat trees that, frankly, are a piece of junk. I mean, they can contain no useful information whatsoever. And so what we've done is taken all that mystery away and built these canonical threat trees, which are a list of all the conditions that can exist that lead to a threat being realized. And I'll give you an example of one later in the presentation. The next one is lacking objectivity. And the big one here is in calculating risk. Now, depending on what sort of risk calculation you use, let's take a couple of examples. One that we have used internally for a long, long time is a thing called DREAD, which is damage potential, reproducibility, exploitability, affected users, and discoverability. And another way of calculating risk, which is very common, is risk is chance of attack multiplied by potential damage. Well, potential damage, you probably have a handle on. Chance of attack? You got no idea. I mean, absolutely no idea. I mean, the weekend before Black Hat in Las Vegas, what's the chance that bad guys will be sniffing around your Cisco routers? Probably, okay, 100%. It wouldn't be any more than the normal noise. But what's the chance that bad guys would have been sniffing around your Cisco network Wednesday afternoon? Very, very high, when there was a paper presented at Black Hat about a vulnerability in Cisco routers that got a lot of press. And so you can't predict the future. You don't know what the potential the chance of attack possibly is you've got no idea whatsoever. It's very much up to people's guesstimates. It also means, do you understand what the possible attacks are tomorrow? There could be brand new attack techniques. There was a paper I was reading a couple of days ago about a way of working out someone's password by listening to the sounds from the keyboard, because different keys make different noises because of the location they are above the main metal plate. Now, a week ago, I can almost guarantee most people didn't think about that. But as of a couple of days ago, it's a potential new attack technique. And so there's a lot of subjectivity in the risk calculation. And one thing that we're doing now is moving away from using numerical-based methods and rather using something that's based on heuristics as opposed to something that's based on magic numbers. So the updated threat modeling process is actually kind of interesting. It looks a lot like the old process, but it actually is substantially different in the middle. So the main things you do are defining scenarios, which is something that you have to do. I mean, we can't do that for you. Create data flow diagrams. Again, you have to do that. We can't do that for you. But the big, sort of the middle three, oh, and by the way, the defining scenarios and creating data flow diagrams, I hope you can do because they require domain expertise, and I hope you understand your application. We certainly don't in security land, but we certainly hope that you understand your application. What's interesting, though, is the main three security critical and security expertise requiring tasks have become rote processes that don't require so much security expertise. So the first one is determining threat types. I'm going to explain all of these in detail in a moment. Leveraging threat trees. And notice we use the word leverage. The verb is leverage. In the old days, it was build. You don't need to build them anymore. We built the threat trees. You just leverage them. And the last one, it used to say calculate risk. The verb now is determine risk. And the reason for that is there's tables that you can use instead, as opposed to actually calculating risk. Planning mitigations is partly manual, partly rote. The rote process is the mitigation technique. The manual side of it is the technology you choose to mitigate the threat. Again, I'm going to explain these in detail. So the first one is defining the key scenarios. Identify what the application does, just so people know what it does. And also bound the application in terms of what threats or what conditions are in and out of scope. And a really good example of this is, say, for a mobile device, looking at the threat models for a mobile device. Is the stolen mobile device in or out of scope? Because if it's in scope, the threat model is going to look different. If it's out of scope, the threat models look different. I mean, it's important to understand whether that particular scenario is in or out of scope. And that's really important. Otherwise, you just start, walking off and spending days and days and days and days threat modeling stuff when you should really be focusing on the core application as opposed to threat modeling the universe. Actually, a really good example, I think I've talked about this many times, but I think it's a good example of a specific scenario was with the release of Windows Server 2003. During the final security review for Windows Server 2003, we asked the IE team to go back to their threat models and think about one scenario. This is an example of bounding the scope. And the scenario was think about an administrator browsing the internet from a domain controller and what threats exist. And so that's why we made the decision in Windows Server 2003 to disable all mobile code by default. That was done in December, and we shipped the product in April. And yet we made those changes to IE just because of the threat models. Next thing is building the data flow diagrams. DFDs have been around forever. They're a very well understood modeling technique. It's old, but it works for us. And the reason why we like to use them is because of the word data. If you look at most serious vulnerabilities, they require malicious data. Not all, but the vast majority. And so data flow diagrams tell us where the data came from. And that's very, very useful to us who are building secure products. So data flow diagram tells you how data enters and leaves and goes across the system. Do not confuse it with a class diagram or a flowchart. They are not the same thing. I have seen some so-called data flow diagrams that are basically function call graphs, that's not a data flow diagram. And if you're trying to threat model every single function you're calling, you're going to hate threat modeling very, very quickly. The one bullet point I will bring your attention to is the second major bullet point. A good data flow diagram is critical to the rest of the process. If you don't get the DFD right, you can't create good threat models. As the old adage goes, you can't make fine wine from bad grapes. And it's the same with DFDs. You've got to have the DFDs right, or at least good enough. They can't be lousy DFDs. In fact, if you look at most whiteboard architectures, if you ask someone, hey, explain the architecture of your application to me on a whiteboard, it will probably look pretty DFD-like. And really the things that we have in a DFD are external entities. It's stuff that you don't control that communicates with you. Process and a multi-process or a complex process. A process is a logical thing. It's not a physical thing. I'm not talking about a .exe here. I'm talking about logical processing. So, an exe may have, n of these things, n of these processes, or these sort of processing units. A multi-process, also called a complex process, is really just a collection of single processes or little bits of discrete processing. Data store is where you stash stuff, and data flow is how stuff moves around the system. Something that we've added to data flow diagrams in the name of security is the privilege boundary. And the reason why we added the privilege boundary was because one of the things we want people to do, and one of the things that we teach developers, is like rule number one. Actually, it's probably rule number two. Rule number 1 and 2 together are, never trust input, never, and always test data or validate data as it crosses a trust boundary. Well, the data flow diagram explains how data moves from one level of trust to another. So, for example, if you have data coming from the internet, crossing a machine boundary, that is a trust boundary. If you have data moving from user context to system context, that's a trust boundary. If you have stuff moving from user mode to kernel, that's a trust boundary. It's where it's traversing trust. And it becomes very, very useful for testers to go and look at the threat model, look at the boundaries, the trust boundaries, and realize they have to start exercising stuff that moves from very low trust to very high trust. You're going to spend more time exercising those code paths. And in fact, if you're reviewing code, one thing you should spend most time on is understanding how when data moves from low trust to high trust and evaluating the code along that code path. So if you've got an entry point into a system that's going from admin to admin, then only an admin can exploit that. But if you've got a data flow that goes from anonymous context to admin context, and there's no authentication, there's a trust boundary there. And if there's a flaw in that code, anonymous users can exploit it. So you better spend more time reviewing that code. And so one thing that we have in the threat model is a ranked list of these trust boundaries and the delta between the trust level. But it works the other way as well. It's not just moving from low trust to high trust. It's moving from high trust to low trust. And it's all to do with information leakage. If any of you are familiar with the classic Bell-LaPadula model, it's all about the secrecy aspect of leaking data from high trust to low trust. So one thing we ask developers to do and testers to watch out for is to look at these trust boundaries and say, well, what sort of data is coming from high trust to low trust? Is it sensitive data? Is it stuff that shouldn't be leaked? And it's just the classic Bell-LaPadula model. In fact, to be honest with you, I think the world could do with, software engineering in general, could do with learning some of the classic models of security. Things like the Bell-LaPadula model, the Clark-Wilson integrity model, and the Biber integrity model. They're really, really useful models to at least understand when you're building your software. So the privilege boundary is actually a very, very useful thing to add to a threat model because it teaches us, okay, where does data move from low trust to high trust? That code had better be good. If it's moving from very low trust to very high trust, that code had better be exceptional because anyone on the internet could potentially exploit that code if there's a vulnerability in it. So privilege boundaries are extremely useful. Some implementation examples of some of these elements in the DFD. External entities could be real people, news feeds, satellite feeds, basically anything that you don't control that is providing input to the system. A process could be a service, could be .exe, could be a web service, could be a single executable with multiple logical processing inside. So for example, a web server, you can represent as a complex process. But inside you have authentication, you have authorization, you have logging, you have ASP, you have ASP.NET, you have WebDAV support, that kind of stuff. They're all sort of logical processes inside of one complex process. A data flow could be a function call. If you're calling out, say, a DLL, most certainly is network traffic. Data stores, again, anywhere where you stack stuff, database, file I/O, registry I/O, that kind of stuff. So there are multiple levels of DFD. The highest level DFD is a thing called the context diagram, which is exceedingly high level. It shows the whole thing on one page, and it looks very, very simple. Then what you do is you drill down and you start looking at the level 0 DFD. So what you do is you pop open the main multi-process or complex process in the context diagram. I'll give you an example of this in a minute. Then you drill down inside of that, and then you take the next complex process and you sort of drill down into that. And so you go from level context down to level 0, down to level 1. Frankly, if you're getting beyond level 2, you're probably stuck in analysis paralysis and really hate threat modeling right now. I've seen some, probably 2 or 3 threat models that went down to like a level 5 DFD. And I spoke to some of the engineers in that group, and I'm like, did you enjoy that experience? It's like, no. It turns out they were just like really stuck in analysis paralysis. So I've yet to see a useful DFD go beyond level 2. So the highest level diagram of the lot is the context diagram. And really all it is, here's the little rule of thumb. In the middle you have your stuff, whatever it is, your CRM program, your web browser. It could be your database system. It could be a game, an internet-connected game. It could be whatever. Then, and that is the single complex process in the middle. Then you have external entities. Who interacts with this system? So in this case, a canonical server example. You have users interacting. You have the admin interacting with this. And so here we have the complex process in the middle. We have the admin doing admin-y stuff and getting logging data back. Users making requests and getting responses back, and that's basically it. And it really gives you a good feel for how many moving parts there are in this system. And again, it also helps you understand one thing you should take care of when you're building the context diagram is what's the privilege level of these users or these roles. What privilege level do they have to be to initiate that data flow? And here you can start thinking about, we've got some low privilege users or a lot of low privilege users doing sensitive stuff with this high privileged process. We need to start thinking about those now. So the next one down, sort of drilling down into that context diagram is the level 0 DFD. So again, here we have the user, here we have the admins, and that complex process in the middle is actually made up of these 4 logical processes and these 3 data stores. And you can also annotate the data flows if you want. So a user makes a request to the service. The service wants to authenticate the user, so it checks out the authentication information in the authentication engine, gets the credentials, does whatever it needs to do, sends authentication information back to the service saying yay or nay. Assuming yes, you can access this data, pulls in the appropriate data from the data store, and then sends it back to the user. At the same time, it logs that data into the audit log and into this data store here. The admin can view that. And also the admin interacts with this management tool to set credentials. So that's essentially the level 0 DFD. Then adding the trust boundaries, there's a trust boundary here. This may be a machine boundary. It almost certainly is a trust boundary relating to privilege level. So this is probably just a normal user, whereas the service is probably running in a slightly elevated privilege or a different privilege. Down here, the authentication engine, you you bet it's running in higher privilege. And in fact, same with the audit engine. In fact, an audit engine must run in higher privilege because it must be a protected entity. And so you have a trust boundary here, and you have a trust boundary here as well as you move from different levels of trust. And notice there's no trust boundary here on sort of this side of things, because assume the admin is the omnipotent being who can manipulate any part of this particular system. That said, you may decide that that's not the case. But again, that then goes back to usage scenarios. Is the admin actually trusted here? Or is there a trust boundary there? So now we get into sort of the heavyweight threat modeling side of things. We've got the data flow diagram done. Now we need to start thinking about the overall threats themselves. The most important thing here is that every element in the DFD, also referred to as an asset, something you want to protect, is susceptible to certain kinds of threats. And this is where Stride comes in. Now, 5 years ago, we actually thought Stride was threat modeling. We were wrong. We were absolutely wrong. Stride is not threat modeling. Stride is a way of categorizing threat types. In fact, Stride is a way of looking at the threats from the attacker's perspective. In other words, the attacker wants to spoof, he wants to tamper, wants to repudiate, those kinds of things. So Stride is, so spoofing is pretending to be, hey, I really am Amazon.com, or I really am Bill Gates, or I am ntdll.dll. You can spoof code, you can spoof servers, you can spoof users, you can spoof computers. People think it's just about spoofing users. It's not. There's a lot of things you can spoof. And in fact, it was kind of interesting. I was speaking to some of the guys in the games division a few days ago. I was doing a presentation at Meltdown, which is a games developers workshop we hold in Seattle every year. Actually, the only reason I enjoy doing it is to speak to all the hardware vendors about the latest gizmos that are coming out. But I was speaking to these guys about threats to games and so on, and it was interesting. They mentioned something that was that I'd never even thought about. A lot of games actually ship with a version of DirectX. And the reason for that is they have built it with that version of DirectX and tested it with that version of DirectX and so on. Well, a lot of hardcore gamers will put the DVD or CD in the disk drive and install. Then at the end, they'll say, do you want to install DirectX version whatever? And they'll say, I've already got that on the system. No. Then the game won't run. So what they then end up doing is going to their favorite search engine and searching for DirectX version whatever. And then that comes a list of some servers that are hosting that file. And then they go and download the file and install it on their machine. Well, it might not be DirectX. It might say it's DirectX, but it may not be DirectX. And so this is an example of spoofing code. And people don't often think about that side of things. They think primarily about spoofing servers or most of the time just spoofing users. Tampering is the ability to change something when you shouldn't be able to change it. Repudiation is an interesting one. I'll be honest, I am absolutely guilty of this. We have probably given repudiation coverage at Microsoft the short shrift. We've never really gone into great detail about repudiation threats. And the reason is that it's an interesting set of issues. Repudiation is the ability to go back on a transaction. So a good example is you decide to sell 100 shares of Widget Corporation at $10 each. You hit the submit button. Just as the confirmation comes back, the stock goes up to $12. The confirmation comes back, you say, I never made that transaction. Why would I make that transaction? The stock's $12 each now. Why would I do that? So now it's up to the brokerage house to prove that you actually made that transaction. What's interesting about repudiation is humans repudiate. Software doesn't repudiate. Software can't really defend against repudiation threats in the truest sense of the word. Basically, the way you repudiate is by dragging someone's backside into court in front of a judge. That's how you go through the repudiation process. And then what you do is you provide evidence, and some of the evidence may be from software, maybe from computers. What's interesting about computer evidence is, certainly in the United States, is computer evidence is treated as hearsay. It is the least valuable evidence you could ever present in court. That said, if you've got a lot of evidence, then perhaps it may sway a judge or a jury. But repudiation is a very interesting thing because most people are not involved in repudiation in the strictest sense of the word. But what you may be called upon in your product is to add technologies to your product to provide evidence in case it's needed in court. So for example, logging is a really great example. Auditing capabilities, time stamping, digital signatures, those kinds of things. They're examples of technologies that can help support repudiation claims. Information disclosure is the ability to view something when you shouldn't be able to view it. And on the surface of it, it seems like, oh yeah, it's just another kind of threat type. It's actually a very worrying threat type. Because if you have an information disclosure threat, and the data underneath that, in other words, the data that could be potentially exposed, is sensitive, confidential, personally identifiable information, you could be open to a lawsuit because of the privacy laws that are around. So you should always treat information disclosure threats very, very seriously and analyze the data underneath it. And that has an effect of bumping up the risk. If you have an information disclosure threat against, say, PII, that bumps up the risk substantially. Denial of service, the ability to knock something out or degrade service. And finally, elevation of privilege, which is the worst of the lot, because if you can elevate privilege, then the other threats can start to become real as well. And by the way, when I talk about elevation of privilege, I don't just mean going from anonymous to admin or user to admin. Anonymous to user could be elevation of privilege. User to local admin could be elevation of privilege. Local admin to domain admin could be elevation of privilege. But it's more than just that as well. It's like in .NET Framework or in Java. If you can gain other permissions that you've not been granted, elevation of privilege. In the case of a browser, if you're running in some sort of restricted mode, but you can break out of that mode and run with more capabilities, elevation of privilege. So it's not just going from user or anonymous to admin. There are many other variants that need to be evaluated as well. Now, here is where we start to talk about the actual threats themselves. So we have a thing called the prime threat, and there's the secondary threat. The prime threat is based solely on the DFD asset type. In other words, it's a data store. Because it's a data store, it's subject to these threats, these stride threats, different types of stride threats. I'll come on to these in a minute in the next slide. Because you're a process, you are subject to these threats. Because you are an external entity, you are subject to these threats, and so on. So, actually, the other thing I want to point out is the secondary threat is based on the threat trees. These are other things you need to think about. And I'll give an example of these threat trees and some of the other things you need to think about. So here is determining the threat types. So every asset is subject to a threat or threats depending on the asset type. So for example, an external entity, you can spoof them. You can repudiate their transactions. You can't tamper necessarily with a user. It tends to be illegal. Processes, you can spoof them. Processes are subject to everything. And in fact, processes are the only things you can elevate against, the only things. Data stores and data flows you can tamper with, you can view them, information disclosure, and you can deny service to them. Although one thing I want to point out is from the attacks or the vulnerabilities that we see, the vast majority of denial of service threats against a data store or a data flow are not against the data store or the data flow. They're against a process at the other end. Like if someone wants to take out a web server, they're probably not going to find the fiber optic cable leading up to the computer room and put a pickaxe through it. They're probably going to attack the web server itself, the process, the web server process. So just be aware of that. I'm not saying there are no denial of service threats against data flows or data stores. There definitely are. But most of the time, it's against the process at either end. But what's also interesting is this one little fly in the ointment is you may have a repudiation threat or threats against data stores if the information stored in the data store can be used for repudiation purposes, such as its logging data, forensics data, that kind of stuff. So now I want to talk quickly about threat trees. The good news about threat trees is we've basically done away with them. We've built a whole bunch of canonical threat trees that you can just leverage as opposed to having to go and build these things. The reason why we sort of realized this is we saw about half a dozen teams who wrote some really, really good threat trees. Then when we looked at them, we thought, they're all kind of the same. I bet there's a bunch of patterns here. And so myself and my colleague, Sean Hernan, sat down and started thinking about this in more detail, and sure enough, these patterns started emerging. And so we built and got a lot of peer review from these canonical threat trees. So a threat tree is just a bunch of security-related preconditions that can lead to the overall threat. And this is why they were a problem in the past. It's a graphical representation, okay, everyone gets that, but of security-relevant preconditions. Unless you're a security guy, you've got no idea what the security-relevant preconditions are, no idea whatsoever. You can make them up, but that's going to be of no use to you. That was one of the critical problems. That's why we're very happy to have moved on to these patterns instead. The very first reference that certainly I can find is from 1993 in Ed Amoroso's wonderful book, Fundamentals of Computer Security Technology. It's a real shame it's out of print now. It's one of my favorite books. If you want a book that's as good as Amoroso's book, and certainly 4 times thicker, I would definitely recommend Matt Bishop's Computer Security, Art and Science. It's an absolutely stunning, stunning book. And also it's got really great coverage of Bell LaPadula, Clark Wilson, and the Biber integrity model. Actually, it's even got a reference to Steve Lipner's, my boss's, the guys up before me, some of the work that he's done as well in this area, the Lipner model. It's derived from, they're derived from hardware fault trees. They've actually been in there for a long, hardware fault trees have been around for a long, long, long time. And so this is nothing really new. We just applied it to security. And as I mentioned before, there are these threat tree patterns that you don't have to keep rebuilding time and time and time again. So with that, let me give you an example. And I hope you can read this. By the way, this is probably about as complex as it gets. There is one threat tree that is actually more complex than this, but basically this is about as complex as it can get. So there are 11 threat tree patterns. Now, when I say there are 11, we found that you can actually compress certain threat trees together. So for example, this here is talking about spoofing a process. It mentions spoofing an interactor. An interactor is just another name for an external entity. So this is about spoofing a process or spoofing a user, for example. So remember we had that grid. Stride down one axis. The other axis was process, external entity, data flow, and data store. Each of those ticks is a starting point for a threat tree. So here's how you spoof, let's say, a user, for example. At the first level here, we have these kind of, I hate to use the term, but I'll use it anyway, these sort of meta threats. And so the way you can spoof a process or a user is by obtaining legitimate credentials, falsifying the credentials, leveraging a lousy authentication mechanism, or there is no authentication mechanism. So okay, how do you obtain legitimate credentials? Well, there's weak storage. Okay, that's great. Weak storage where? At the server, at the client, or in the key distribution center, if you have a KDC. What's cool about this is what we've done is essentially built a whole bunch of security expertise into these trees, and on the leaf nodes, there are questions you can ask. So, do you store the user's credential at the server? No. Okay, next question. The answer is yes. How do you protect it? Do you store the user's credential at the client? Yes or no? If the answer is yes, how do you protect it? Do you have a KDC? No. Okay, weak transit. How do you transfer the credential from the client to the server? Well, we do it this way. How secure is that? Weak change management. All this may be very, very secure until you decide to change the password or the credential. So how do you make sure that's secure? You see what we're driving at? These leaf nodes are just security expertise that's sort of just been bottled up in these threat trees. There's a whole bunch of questions that we can ask people. So falsifying credentials. Is there any way of guessing the password? Anyone care to guess what the question is we would ask at this point? What's your password complexity policy? Do you have one? If the answer is no, that's a risk. That's a real threat. If the answer is yes, and it's like 11 characters, alphanumeric, uppercase, lowercase, and punctuation, that's probably fine. Equivalence. Is there any way that 2 credentials could actually be the same? Great example, DES. DES has 4 weak keys, where you can encrypt with one key and decrypt with the other and get the same plain text back. And it has 16 pairs of semi-weak keys. You encrypt with one key, decrypt with the other semi-weak key, get the same plain text back. Do you have that? Does that capability exist? Are there certain credentials that could be classed as being equivalent? Now, do you support the notion of a null credential? Do you support a less secure or a lesser secure authentication scheme? You could ship with version 2 enabled by default, but if a client says, I don't do version 2, I only do version 1, and so the server rolls back to version 1 immediately, like, well, what's the point of even shipping version 2? The attackers are not going to use it. They'll use version 1. And so do you have a downgraded authentication scheme? Predictable credentials. I have seen websites where you type your username and password and it gives you a cookie back. That then becomes your credential. I've seen some websites where that cookie, they have a really, really strong password complexity policy, but the cookie is an atomically incrementing value. So you hit it once, cookie comes back, 1. Okay, let's call it 1001. Hit this website again, 1002. Hit it again, 1003. You're doing new logons with your valid account. Then you wait 5 minutes. Then you force a cookie to be 1004. You probably just hijacked someone else's session right now because it's a predictable credential. The cookie, you could have a really, really strong password, but the cookie has now become the credential. And if it's a weak or predictable cookie, I'm not going to attack the passwords. I'm going to attack the cookies instead. The other one that's an important point about these threat trees is they chain. So one thing I can do is I can try to attack the authentication process. Let's take a really good example of this. Let's say you decide that I'm going to protect all my binaries by digitally signing them. And so when they load, there's some process that verifies the digital signature is correct. Are you going to attack the crypto on those blobs? No. What I'm going to do, I'm going to attack the authentication process. So it says, yeah, the digital signature is correct every single time. I'm not going to attack the crypto for crying out loud. I'm going to attack the authentication process. And so what you do then is you then take the tampering threat against the authentication process, which is just tampering against the process, and take that threat tree. How have you protected the authentication process? And so on and so on and so on. Like I said, there are 11 of these things. And the really cool thing about this is on the Leaf nodes, there are questions you can ask developers and designers. How are you storing the passwords? How are they protected? How are they used in transit? Do you have a complexity policy? How are you protecting the authentication process? But then you can start thinking evil, and there are evil questions you can start asking, which is if you're a tester, here are ways you can go to attack the authentication process. Here are ways you can go and discover how the password is stored. And so you can actually give very prescriptive guidance here, not just for designers, but also for testers as well, and for developers, about how they should go about testing the system. So I want to point out again, there are two sort of categories of threats that we end up worrying about, the primary threat and the secondary threat. The primary threat is really just an intersection of stride and the DFD element type. So if you're a data store, you are subject to tampering, possibly repudiation, information disclosure, and denial of service. But there are other conditions you need to think about as well, and they fall out of the leaf nodes of these threat trees. What's also kind of cool from the one thing that we've learned is that if you have all these assets and you have a big DFD, you end up with a lot of threats to look at, a heck of a lot of threats. What's really nice is you can actually do some sort of threat reduction. So let me give you a real good example. Let's say you have, actually let me give you a real example. We were doing the threat model about 9 months ago, or updating the threat model about 9 months ago for services for Macintosh and Windows. And basically there are two big chunks of SFM, file, print. The processes that do file or print live behind the same trust boundary. They are written in the same language, and they're kind of very similar. We could actually have threat modeled both those processes separately. But because they're behind the same trust boundary and written in similar technology, actually the same technology, they're both a service written in C, we just threat model them as one unit rather than 2 units. Saves a lot of time, a heck of a lot of time. So now we move on to calculating risk. So in the past, as I mentioned, we used DREAD. We used DREAD a lot. The problem with DREAD and anything based on numbers is it's extremely subjective. You can guarantee you get a dozen people in a room, and they'll fight for an hour, and come up with 15 results. So we want to move away from that because we've actually seen a lot of wasted time arguing about what the risk really is of something. It's extremely subjective and often requires, I've been called to go into many threat modeling meetings to basically, be the final say on the risk of something, which I always err on the side of you got to fix it. And on a scale of 0 to 1, I mean, just how likely is it? As an example, how likely is it that an attacker could access this private key? It's being protected using data protection API, and the blob is stored in the registry with a protected ACL. I mean, what's the likelihood that someone could compromise that? It's a really, really hard thing to really work out because it assumes you know future attacks. And the other thing is, where do you draw the line? Let's say you have a stack ranking between 0 and 1. Where do you draw the line? Everything above this value will fix. Everything below this, we either won't fix or we'll remove from the product or something. Where do you draw the line? It's very, very subjective. So what we've done, and we're getting a lot of praise within the company from development groups around this. What we've done rather than using numbers is use these heuristics, which are simple rules of thumb, but they're not random. What we've done is gone back to the Microsoft Security Response Center rankings, which have been around for a long, long, long time, and taken the work they've done and just extrapolated it a little bit more. So the Microsoft Security Response Center, when we issue a security bulletin, there's a bunch of information in there, including threat type. If you ever look at an MSRC bug, there's always a threat, like the actual threat. Spoofing, tampering. I've yet to see a repudiation bug. Information disclosure, denial of service, elevation of privilege. They use Stride. Then there's an overall severity from low, moderate, important, and critical. And so what we've done is we've gone back to the MSRC bugs, or the rankings, and just extrapolated to make it sort of this kind of hypercube. So what we have Stride on one axis, server, client. On another axis, local, remote, authenticated, unauthenticated. A couple of little things in there as well. So for example, in denial of service, is this a permanent DOS, or does the system come back when the attack stops? For information disclosure, is there PII, or sensitive data? So there's a couple of little tweaky things in there as well. And so we can just look at an issue in the threat model and say, well, this is a spoofing threat against the server, and it's unauthenticated. It comes from the threat model, and it's remote. Ding, 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 critical. Got to fix it. And basically, criticals and importance, you absolutely, categorically have to fix. If you're like 2 days out from shipping the product, and you find a critical issue that you haven't thought about, you've got to fix it. Moderates are all the way up to the release candidate phase, and usually have a little bit of discussion. And low is kind of at your discretion. So for example, critical, if you can run malicious code, that's critical. Most elevation of privilege vulnerability, the vast majority of elevation of privilege vulnerabilities are critical as well. Important is denial of service against the server, where the server stops. It's now dead. That's important. Moderate is if, say for example, a server DOS, where the attack stops and then the service resumes. And low is, say, a DOS against the client. So you load your browser, you go to a website, and the browser hangs. That's low. But a lot of these are documented up on the MSRC website. So the next thing is, so now I end up with this heuristically generated stack rank list of threats. And now you got to work out, well, what do we do next? How do we fix these? So you now got to think about mitigating the threats themselves. So how do you remedy these? And there really are a bunch of options. I mean, you could leave as is. If the risk is just so low, it may be appropriate to leave as is. It may be appropriate. I'm not saying it is, but it may be appropriate to leave it as is. Remove it from the product. Let me tell you a little story. This was about 18 months ago. I was asked to go to a meeting. It was a Longhorn feature. What was Longhorn back then? And basically, the guys had done their threat models. They said, look, we really want to do this feature. It's a really cool feature. It'll benefit a lot of customers. But when we built the threat models, we realized how scary this was. It had the number one user could be the bad guys. And I'll tell you right now, if the number one user of a feature is the bad guys, you get rid of the feature. Really good example, SQL Server 2005, XP_command shell, disabled by default. Because the most common users are the bad guys. It's time to cut it from the product. Number one user of tftp.exe in Windows Server 2003, bad guys. So it's not there in Windows Server 2003 Service Pack 1. We just removed it. So you may decide to remove from the product. So I had this meeting, and they said, look, we really want to do this. We haven't built anything. We've just sort of architected it, but that's all we've done. We built the threat models, and this just worries us. Can you please come and review it for us, make sure we're not missing anything? And so it was a 2-hour meeting. The meeting lasted 7 minutes. So, well, I love meetings like that. It's like, great, go and get another coffee. So we looked at the threat models, and it was like, yeah, you're dead right. The number one user of this feature with cool feature for the bad guys. So, but I'm not just going to walk out of the meeting at this point. Let's look at mitigations. So we looked at the mitigations, and the mitigations ended up being, well, we can mitigate it, we really can, but the feature will be of no use to anyone. No one could use it. Really damn secure, total waste of time. So it's like, so what do we have? Build something where the attackers are going to be the number one user, or no one can use it. So the decision was neither. The decision was to remove that feature from the product altogether. That feature is not in Windows Vista. And unless we find a better way of doing it, it will never be in Windows Vista. It will never be in a Microsoft product. So it was an extensibility feature. It will take me ages to explain it. So now compare that to, say, 5 years ago. And something that Mike Nash said in the video is so true. Things have changed dramatically to err on the side of security. So this is an example where I can almost guarantee 5 years ago, that puppy would have been built. It would have been built, would have taken 10,000 person years to build, test, design, document, blah, blah, blah. 10,000 hours. 3 weeks from shipping, someone in our group would have said, what's that? What? Lift the rock up? What the hell is that? You can't ship this, guys. No. So, but then what do? So they pull it from the product, right? 3 weeks to go until shipping. 5 other components in Windows depend on that feature being there. They've now all got regressions. Everyone's running around like the sky is falling because you've introduced all these bugs into the system, and it's taken 10,000 hours to build this thing. No one's won. Everyone just gets really wound up before you ship the product, and everyone hates it the few months before you ship a product. It's just, it's a lot of work. So we never went through that, right? That feature never even saw the light of day. When we actually look at the amount of work they'd spent designing and threat modeling this thing, they spent a grand total in the threat modeling exercise about 5 hours threat modeling it. I don't know how much they spent actually designing it. I don't think it was that much. It was a huge number of hours. But compared to building, testing, and documenting and debugging this thing, which may have been in excess of 10,000 person hours, totally wasted. That's one thing I love about the threat modeling process. It helps you find all these issues before they even get built. You can remedy with a technology countermeasure, and I'll talk about that in a minute. And the last one is warn the user. Now, warning the user is never really the greatest thing to do. Now, I'm not going to say that you should never do it. But if I see your threat models and they say, inform user, inform user, inform user, inform user, no, you don't do that. And the reason is most users don't make good trust decisions. They just don't. That's why the I love you virus was so successful. Right? Oh, someone loves me, ain't that nice? Rule number one, if someone sends you an email saying they love you, you don't deserve to love them back. Right? My mother always told me you tell people to their face. My mom's always right. And it's like, click here to speed up your internet connection. What's that all about? It's like, click here to change the laws of physics, or click here to knock everyone, off your local DSL network so you have all the bandwidth. Or, you know, the best one is, do you have spyware? Well, you do now. It's like, people don't make good trust decisions. I'm not saying, they're not stupid. Don't get me wrong, they're not stupid. People just don't necessarily understand the security ramifications of the decisions they're going to make. They just don't. And that's why I take my hat off to the IE guys in Windows XP SP2. They removed a lot of the dialog boxes that say, do you trust this ActiveX control? Yeah. It's like, no. It's like, we blocked active content. We blocked pop-ups. We blocked this. We blocked that. I'm surprised the browser's still working. We blocked this. It's like, but that's the right thing to do. Just take the default situation, the secure, and then if people want to change the policy, go ahead, change the policy. That's a very, very, very discrete task that the user is doing at that point. So I'm not saying don't warn the user. Just be very wary of pushing the security of your feature or your product onto the users. That's the wrong thing to do. You should always look at how you can default to a secure system and inform the user of what happened. That's a much better situation. So when it comes to planning mitigations, remember I said when it comes to the mitigation phase, you've really got two parts. You've got a rote part and you've got a manual part. The rote part is the broad brush technique that you could apply to mitigate this threat. And as I say technique and not technology. From these techniques outfall technologies. So for spoofing, you could use authentication. That's a technique you could apply. For tampering, you could do integrity. And then for repudiation, you could use non-repudiation. That's useful. No, seriously, there are non-repudiation technologies. There's just a lot of them. There was a version of this slide that we had as a joke once, which was you mitigate spoofing threats with non-spoofing mitigations and tampering with non-tampering. Didn't go down very well. So that's the broad brush technique that you can apply. And out from that, there are technologies that you can actually choose from. Again, it's really important to understand that threat models help drive the design, they can help drive the development, and they can help drive the testing. It's a really fundamental part of building the products at Microsoft now. They help drive so much more of the development effort around thinking about the security of the product. So one thing I want to go through now is a real simple example of a tool I wrote. It's very, very similar to the classic a tripwire tool. And I just nicknamed it Integrity, just a nickname for it. Very, very similar to tripwire. The big difference is, I got to be honest with you, I've not used tripwire for a long, long, long time. It can work on remote machines, and you can have scan multiple machines. So the way tripwire works, the way integrity works, is you can say, give me the information about that, say that directory, and it will return the files in the directory. It will return the creation dates and modified dates and so on. And it will also hash the content as well, and then return that data. It's a classic integrity checking tool. You may want to use it for forensics, for example. So in the case of Windows, you would possibly get a stable system. You could enumerate, say, the System32 directory, and that should never change. And before you do apply, say, a service pack or a hotfix, you can just double check nothing's changed, then apply the service pack, and then baseline the System32 directory, for example. So this is the context diagram for the integrity tool. The only external entity is the administrator. There should be no one else tinkering with this. And then it communicates with this complex process or multiprocess, which is the integrity application itself. Then the level 0 DFD, just drilling down a little bit further, you've got the admin talking to a console app. And the console then communicates with any number of host implementations over the network. So there's a trust boundary here, obviously, because it's over the network. Over the back end, it could read configuration information, and it can read information from the file system, which is actually the core information that it wants to read. And it could even read information from the registry. You could say, give me information about this registry key, for example. So an instruction would come from here, go over here, and say, enumerate this directory. Then back would come the integrity data, file name, creation information, modified information, SHA-256 hash, or something like that. And then that information is then stashed away in this integrity file here. It could be, say, an XML file that stores all the information by server and by file information as well. So then what I can do is I can then get the data back at a later date and do a diff and see if anything actually changed. And if it did change, that's interesting. I wonder why it changed. So first thing we do is identify all the DFD assets. That's just a rote process. You just count all the elements up, and that's essentially it. So there's one external entity, the admin. There's two processes, 2 and 3, et cetera, et cetera. Then you identify all the threat types. So we take each of the elements. So external entities subject to spoofing and repudiation, because it says so here. Element number 1, that's the admin. And then say, for example, this, I don't know, pick on something. This process, element number 3, it's a process. Element number 3, there's 2 of them, 3 and 2. It's a process. It's subject to stride. So now we end up with this list of all the potential threats in the system. So the next thing you do, and this is actually part of a lab exercise that I have. And to be honest with you, if you want to copy the lab exercise, you're more than welcome to it. You're more than welcome to send me an email, and I'll send you the lab exercise. And the lab exercise we ask people is to identify 3 threats, 1 for data flow, 1 for data store, 1 for a process in this. So here's the first one. So looking at this server component, it's a process. It is therefore subject to stride, everything. But we're going to focus on just on the spoofing threat, spoofing that server process. We're going to look at this one data flow. So data flow is subject to tampering, information disclosure, and denial of service. I'm going to look at just one threat, the information disclosure threat. And the last one is the integrity file down the bottom there is subject to tampering. It's also subject to repudiation threats, because if I can whack that file, I can cover my tracks. I can completely cover my tracks. So it's subject to repudiation issues, information disclosure, and denial of service. So the next question we ask people is, okay, now look at first-order mitigations for each threat. So, pop quiz, spoofing threat against the process. How do you mitigate spoofing threats? What's the technique? Not technology, technique. Authentication. And there's a bunch of technologies you could use. You could use SSL. You could use IPsec. You could use Kerberos. You could use NTLM. Actually, you can't use NTLM. You could use BASIC. Actually, you can't use BASIC. And the reason why you can't is because NTLM and BASIC don't authenticate the server. They only authenticate the client. You can't use those technologies. So here's a little pop quiz. Could you use SSL to authenticate the host integrity software? Can you use SSL to authenticate that that really is foo.exe? Can you do that? No, you can't. SSL stops at the box. You know it's that box. Does anyone care to take a stab at a real technology that you could use to authenticate that that really is foo.exe listening on port 1234? Two-way authentication? No, because you're authenticating a client. I mean, we don't care about the client in this case. We only care about authenticating the server. Kerberos. Kerberos authenticates the server, and it authenticates the software. That's why in Windows Server 2003, we have constrained delegation. We can actually constrain the delegation to a specific service. We can say, you can delegate to that box, but only to SQL Server on that box. We can do that because Kerberos supports it. So you can use Kerberos. The problem is, would you use Kerberos? This requires you have a domain in place. You may not have a domain in place, which then means you can't use Kerberos. What you could possibly do, and this is a little bit hacky, is you could actually use extended key usage in the SSL certificate. And you can actually define your own OID, your own object ID, that says host integrity software authentication. Then you can actually issue your own certificate, assuming you trust the root CA, of course, and apply it to that software. And that way, the client can actually validate that the extended key usage is for this host integrity software authentication. That could possibly work. That's certainly a solution. In this case, we're going to use SSL TLS. We may say, you know what, we're going to stop at the box, and we're going to go that far anyway. But you're not really mitigating the threat against spoofing the process, though. But you may decide to do it if you want to go this extended key usage use. What's the best solution? That's a really good question. There is no best solution here. There really isn't. Sorry, I don't get the question. If you're an attacker and you could make what happen? That's a really good point. If you can spoof the process by replacing it with something else, but here's a funny thing. This tool is kind of a chicken and egg problem, because this tool is designed to check whether stuff like tampering and replacing bits has actually happened or not. So it's a really difficult problem to solve in this particular example. I've got an idea. I'm actually really running out of time. So let's talk about it in the break. There is no great solution here. The next one is the information disclosure threat against the data coming back. So what technique can you apply to mitigate information disclosure threats? Use confidentiality, aka encryption. Guess what? SSL gives you that. In fact, what's even better is SSL also mitigates the tampering threat too, because it uses message authentication codes. So if you can actually kill 3 birds with 1 stone, that may be worthwhile. Now compare that to, say, using SSL for encryption and tamper resistance and Kerberos at the same time to authenticate the server. That could become, a pretty unwieldy product that you may not want to actually deploy. And the last one is a tampering threat against the integrity file. And there's a bunch of different techniques that you can apply here, different integrity techniques. You could use an access control list. Only host integrity administrators can manipulate this. You could use a digital signature. You may decide to use a message authentication code. You may want to, depending on how simplistic you want to be, or sort of lower infrastructure, you may want to go the message authentication code route as opposed to a digital signature route, which means you've got to have all this PKI in place, and you've got to look at critical distribution points and verify that a certificate's not been revoked and that kind of stuff. So how do you work this out if you're on an airplane with no internet connection? I mean, how do you check the CDP? You can't. So again, you've got these techniques that you can apply, and there are technologies that you're then going to look at and say, well, what's the most appropriate one for me to use here? You may not have an absolutely perfect solution. You may have one that's good enough. And then looking at the risk, you may say, okay, the risk is reduced to an acceptable level by using this mitigation. We'll go with that. It's not 100% perfect, but it's easy to use, it's understandable, it's proven, and it reduces risk to an acceptable level of risk that the business is willing to accept. So a quick summary. The threat modeling process is, as I mentioned before, we've really sort of fine-tuned over the last couple of years, and most definitely over the last 9 months. So it's really just defining key scenarios. Like, these are the scenarios we're really going to care about. And these are scenarios that are out of scope. We're not going to care about these. You model the app using data flow diagrams just because they're dead easy, frankly, and they work pretty well. Determine threat types. That's rote. DFD element, processes, external entities, data flows, data stores, and then stride. And there's that matrix that you follow. And that gives you the prime threat. And then from that, you can then go to the appropriate threat trees. And there's a bunch of questions you should also ask yourself as well. Determine risk. Again, you can use numerical methods. We're not saying you can't. I mean, absolutely do whatever you want. But we're finding that moving to a less numbers-focused leads to fewer arguments and faster decisions. Like blah, 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 blah. That's important. You have to fix it. It's as simple as that. It's a much more streamlined process doing it that way. And again, finally, planning mitigations. And there are 2 things to think about: the overall mitigation technique, authentication techniques, authorization techniques, confidentiality, and so on. And then the hard part, which is actually the technologies. What works? What doesn't work? What's the most appropriate thing? Could we use this technology to fix this problem? The next question you need to ask yourself is, would you use it? Does it make sense to use this technology to solve this specific problem? Some of the threat modeling resources, there's actually a threat modeling website where we have a threat modeling tool, and we have references to a lot of other threat modeling material up there as well. One link that's not up here, if you ever get a moment, go to blogs.msdn.com, PTOR, P-T-O-R-R. And Peter is a colleague of mine. Actually, he's another Australian. I promise not telling the Australian jokes. On guerrilla threat modeling. And it's actually a very, very good document on rapid threat modeling. And it breaks a lot of the mysteries around the threat modeling process. So I'd urge you to go and look at Peter's blog entry on guerrilla threat modeling. That's not gorilla as in furry creature, it's the other threat, the other gorilla. So with that, I am done. Mention the book. Oh yeah, well, the 19 Sins book? Which? Oh, the threat modeling book. I'm sorry. The threat modeling book. So the threat modeling book is available from Microsoft Press. It's written by two colleagues that work in our group. Excellent book. It's only a short book. It's like 250 pages long. Probably read it in a weekend pretty easily. Goes over the process in depth. Writing Secure Code, second edition, does cover threat modeling as well, but it's only one chapter. The threat modeling book is a book dedicated to the subject. And that's for, just while I'm up here, you're all getting copies of the 19 Deadly Sins book, which is written by myself, my good friend David LeBlanc, and a good open source security friend of ours, John Viega. You're all getting copies of that. I'm more than happy to sign it. If you want me to sign it, adds exactly 34 cents to the value of the book, but I'm quite happy to sign it. So with that, we can probably take questions.
Let's see, two things. One, they're going to kill me if I don't mention this now. I should have mentioned it before. You have a questionnaire on your chair. There's a pre-symposium questions, so I'd ask you to cast your mind back to this morning before I started talking and fill in the questions on the pre-symposium side. And then the post-symposium questions, I believe they want you to fill out after we're done at noon. And I also believe they may hold you up for the questionnaire in exchange for the book. I believe that's the protocol. So with that formality out of the way, somebody will correct me if I got that wrong. I think we can probably take one or two questions and then give you a break. Break goes till 10:30.
Yeah, so good question.
Repeat it.
The question is, are those attack trees published? They should be in the slide deck. If they're not, we'll add them. It's a good question. Ali, where do we get this slide deck?
They'll be posted online on the ComNet. Probably by Monday, this version will be up there, and then you'll be getting your DVDs that will be the full recorded video and everything.
And I'll make sure the threat tree patterns are in there.
So it'll be on the ComNet by Monday, and you'll get it. The slide deck will be on the DVD as well. There's one more question there.
Yeah, great question. The question is the threat modeling tool going to be updated? The answer is yes. We're actually in the throes of doing that right now. There's no time frame just yet for getting it complete, but we absolutely are updating the threat modeling tool to represent the new streamlined process with the new threat trees. But there's no time frame just yet. But we absolutely are doing it.
Let's take one more.
Take one more if we have any. Is a threat modeling tool in managed code? It most certainly is, written in C#. Okay, so we'll see you back here at 10:30.
Thanks very much.